Okay, question 15. A roller coaster ramp has been adjusted from its original position. The roller coaster has approached the peak of the ramp and is about to descend. The equation h sub t is equal to 3t squared minus 48t plus 210 illustrates the location of the roller coaster in yards after t seconds. What is the roller coaster at 10 seconds? So since our t represents our quantity of seconds, we can plug in a t, 10 for t. So h of 10 is equal to 3 times 10 squared minus 48 times 10 plus 200 and, oops, I left off my 10. All right. 10 squared is 100 times 3 gives me 300 minus 48 times 10 would be 480 plus 210. So we have 300 minus 480 plus 210. So h of 10 is equal to 30. Now what does 30 represent? We were told yards. So h of 10 is equal to 30 yards. What is the minimum height of the roller coaster in its new location? Well, the new location that we're talking about is the location based on our quadratic. So the minimum height, if I had a quadratic, is going to be way down here. Well, that's the vertex, isn't it? So our minimum height is going to be the lowest value in our vertex. Well, x values are seconds, so moving left to right would be seconds. Up and down would be yards. So we want to know at the vertex, what is the y value so that we can account for the quantity of yards. Now I would start by finding the value of my vertex x. X is equal to negative b over 2a, which is equal to 48 over 2 times 3. So 48 over 6 is equal to 8. So at an x value of 8, which is our axis of symmetry, what is the y value that would represent our minimum height? So again, we want to plug in a value for t. H of 8 is equal to 3 times 8 squared minus 48 times 8 plus 210. Now, I'm not going to do all these in my head. 8 and 8 is 64 times 3 gives me 192 minus 48 times 8 gives me 384 plus 210. So 192 minus 384 plus 210 gives me a h of 8 that is equal to 18. Well, this tells me our vertex is 818. So the distance, or the lowest distance of the roller coaster at its new location is 18 yards. Find the time after the roller coaster changes directions. Well, when does it change directions? From the beginning all the way down to the lowest point, it's descending. Well, when does it start ascending? We already found that time, didn't we? That was the x value of our vertex, which we found in the previous problem. So that's going to be 8 seconds. What does the y-intercept tell us about this situation? All right. Well, let's figure out what the y-intercept is. The y-intercept on this particular graph tells us that we have an x of 0. So if our x is equal to 0, no time has passed. That's going to tell us the starting location or starting height for our coaster. So let's figure out what that starting height is. The nice thing about finding an x of 0 is it cancels out a lot of our other values. So 3t squared, if t is 0, that's going to be 0, minus 48 times 0, that's going to be 0. So add an x of 0, my y value is equal to 210 yards. So the roller coaster at its beginning starts at 210 yards.